All right, guys, welcome back from winter break. I hope you all are rested and had a great time over your holiday week. Sorry I can't be here. My daughter is pretty sick, and I have to take her to the doctor this morning. So, in the place of a lesson, you guys are going to have a video. Good news is that today it's going to be new material, quote unquote, new material, but really all we're doing is combining some things you already know. But what we're going to do first is review a little bit what we already know about solving systems, okay? So what I want you guys to do today for the video lesson is to follow along and fill out the notes as if you were in class, and my instructions are for the sub to pause the video whenever you guys feel like it. You'll probably have to do that because I'll be going faster than what I would normally do in a normal class. This video will be posted to the Moodle page, so you can access it at any time. A couple reminders as we move into the week here. You guys have a test you can see up on the right-hand side of the board on Monday of Tuesday of next week. Thursday, Friday this week we'll be reviewing for that test. So unfortunately, yes, Monday, Tuesday test is not super convenient, but it is what it is. So make sure you're preparing for that. All right. I want you guys to try these problems on your own. So my instructions for the sub are to first pause and let you guys try these. Remember, the first one is asking you to solve using substitution. Second one is asking you to solve using elimination. And then on the bottom of that first page, I also want you to solve the system using graphing. But I want you to change this 14 to a 7. And I want you to change the 13 here to a 2. Obviously, the y-intercepts here of negative 14 and 13 don't fit on the graph that I gave you. So, and then I want you to try on your own graphing the linear inequality. Remember, you have to solve for y first, and then remember flipping the sign when we divide by a negative, if that's possible here. And that these two questions here are really what we're going to be focusing on today. We're going to basically combine these two things. So go ahead and pause the video, and then we'll continue on with the lesson here. All right, hopefully you paused it and were able to do that. This first question here is being solved by using substitution. So if we're using substitution, remember if I have y equal to something, I can take that something and substitute it in for y. So that's going to go right here. Let me see if I can get a little bit of a finer marker here. Cool. All right, so then what I'll write is 9x. Sorry for the sloppy handwriting here. I'm trying to write it on a slate, and it's not working out too well, so bear with me. So I have 9x plus 3, and instead of y, I put in parentheses negative 3x plus 1. And then I finish writing out that equation, equals 12. Okay? Well, what do I have to do? I first have to distribute this 3. That'll leave me with 9x plus negative 9x. Hopefully you're starting to think about what's going to happen there. Plus 3 is equal to 12. Well, what happens to the 9x's? They're gone when we combine like terms, and I'm left with this statement of 3 is equal to 12. And if you remember what happens here, what we have is a false statement, and this is no solution. That means if you were to graph these two lines, they would never intersect. They would have the same slope but different y-intercepts. Okay, so that's the first one using substitution. Let me get rid of this so I can have more space. Okay, so then, yeah, the elimination method. If I'm x's, y's, and equal signs are all lined up here, so that's good. What I'm going to do is multiply the top equation by negative 1, because then I'll have my y's cancel out. So I'll have negative 5x minus y is equal to negative 8. And what happens? 2 minus 5 gives me negative 3x. My y's cancel out, and that's going to be equal to negative 8. Okay. Oh, sorry, not negative 8. I'm going to add those two together. Take a step back, not negative 8. All right. So again, negative 3x equals, and then I have 5 minus 8, sorry, to give me negative 3. All right, then I divide both sides by negative 3, and I get x is equal to positive 1. Now at this point, what do I do with that x is equal to 1? I shove that back into one of these equations here. I'll pick the top equation, so I'll have 5, and then instead of x, I'll have a 1 plus y, that's a plus sign, equals 8. And I subtract 5 from both sides, and I get y is equal to 3. So I have the coordinate point 1, comma 3. And again, if I were to graph these, that's where they would intersect. All right, next warm-up question. I have to graph both of these. My y-intercept for this one is positive 7, so that's going to be 3 from the top. So my y-intercept is here. And then I have a slope of, negative 7. Trying to go fast in the morning doesn't work real well. Negative 7, so that's going to be down here. And I have a slope of positive 7, so I'm going to go up 7, right 1. And then up 7 more, which would be there, right 1. And so I have a line, this is going to be tough with this slate. It looks roughly something like this. Yeah, that's not so great. The other one has a y-intercept of 2, and that would be here, and a slope of negative 2. So I go down 2, right 1, down 2, right 1, down 2, right 1. And I've put my pencil right on the solution. There's my line. And what is the solution here? The solution where they intersect is 1, comma 0. All right. And then solving the linear inequality here and graphing it, I have to solve for y, so I'm going to subtract 8x from both sides. Minus 8x. That'll give me negative 4y is greater than or equal to negative 8x plus 12. If I divide both sides by negative 4, everything gets divided by negative 4. I'll end up with y is then less than or equal to negative 8 divided by negative 4 is positive 2x, and then 12 divided by negative 4 is negative 3. So I go to negative 3 for my y-intercept. I have a positive 2 slope, up 2, right 1, up 2, right 1. And don't forget for inequalities, we have to decide, is it solid or dashed? And so if I look at my linear inequality right now, I have a line underneath, so I'm going to graph a solid line. Oh boy, holy cow. All right, try that again. I'm going to graph a solid line. This is going to be tough today. And then it is solved for y, which means I can use the rules of if it's less than, I can shade below. So there we go, shading below. Cool. All right, that's the warm-up. So what are we doing today? We are practicing how to solve and graph systems of linear inequalities. So we're combining basically the idea of graphing a system of equations to see where they intersect with the idea of graphing a linear inequality where we shade on both sides. The result would be, let's say I graphed another linear inequality on the same graph. Let's say it looked like this and it was a dashed line, and now I had to shade below. Let me pick a different color. Okay. Now if I shaded below, my double shaded region would be right here, and that is the solution to a system of linear inequalities. So all we're doing today is graphing 2 or 3 linear inequalities on a graph, and then going ahead and saying, oh, the double shaded region is here. Okay, so in this case it would be here for that other line, and that's my answer. Okay, so let's practice that with this one. So I'll graph this one in yellow. So I have x is greater than 2. So that is a, what kind of line? That's a vertical line through 2. So it is dashed. So there's my dashed line. Do this the best I can. And it's greater than 2. So where are the things that are greater than 2? To the right. So I shade everything to the right of that line. I'll do the other one in blue. Okay. So I have y is greater than or equal to 1. Well, that's a horizontal line at 1. So there's that line, and it's greater than or equal to. So I shade above. And you'll notice I have a double shaded region right here. That is the solution to my system of inequalities. So you notice I have a practice graph and an answer graph. If you think that your practice graph looks really good, you look at it, you're like, hey, Mr. Vespa, I can definitely tell what the double shaded region is. You do not have to use the answer graph. However, if you're unsure of what I will think your answer is, the best thing to do is to go over and use the answer graph. So I'll graph both of those lines again, but now since I know where the double shaded region is, I will only shade that part. So now I know the double shaded region is here, and so you can use your answer graph that way. You don't have to do that, but it's there for you to try. So now let's try something that's a little bit more complicated. Why haven't I gotten rid of this thing yet? Okay. I have a y-intercept of 4 for the top line, 1, 2, 3, 4. And I have a slope of -2 down to right 1, down to right 1, down to right 1, down to right 1. And I'll go back up this way. And so there's my line. I noticed, I got off a little bit there. It's really here. And so I noticed that is a dashed line, so I'll try to dash that as much as possible. And so there is my dashed line. I noticed that it is less than and solved for y, so I can shade underneath that line. So there's my dashed line for that one. I'll do the other one in a different color. So I'll use this one, and I have to solve this one for y. So I will have to subtract 3x from both sides. So minus 3x minus 3x. That gives me -2y is greater than or equal to -3x plus 12. If I divide both sides by -2, I will end up with y is less than or equal to, now I got to switch signs, -3 divided by -2 is 3 over 2x. I'm going to leave that fraction. And then 12 divided by -2 is -6. So I have a y-intercept of -6. And so that's going to be 1, 2, 3, 4, 5, 6 right here. I have a slope of 3 over 2. So I go up 1, 2, 3, right 1, 2. 1, 2, 3, 1, 2. And I can do it exactly backwards. Down 3, left 2. I know that's going to be a solid line because I see a line underneath. And it is less than, so I'm going to shade below. And I know I don't have to go into the other region because the only part that will be double shaded is right here. So if your graph ends up looking like this in the end, I would say you do not have to go and use the answer graph, okay? But if, again, you're not sure on what you're thinking I will notice on your graph, go ahead and clean it up. Basically, erasing the other part of the graph here. You can get rid of that, you can erase it, but it's probably easier to just graph those two lines again over here. So however you want to do it, just make sure it's very clear what is what. All right, now we got 3 of them. So again, I will graph them in 3 different colors. I should probably use a marker instead. So I'll do this one in black, and I'll have to select a skinnier one. And so I have y is less than 3. That is a horizontal line through 3. 1, 2, 3 is right there. It is a dashed line, so I'll try to dash that as best as I can. And less than means I'm shading below. So here's another tip. Check out what I'm going to do. I know I'm going to shade below, so instead of actually shading it, I'm just going to put an arrow. That's a note to myself to say, oh, hey, back when you go fill in your final answer, you're going to shade below this line, okay? So then I'll select a different color and say, all right, I get x is greater than -2. So -2 is right here. That is a vertical line through 2, so I'll dash that line up and down. And greater than is going to be to the right. So now up here, I'm going to make a little note to myself. I'm going to shade to the right. So right now, I'm restricted to this little box here. Okay. Now I just have to have graph one more line. I'll do that in orange, or whatever this color is, colorblind. And I have a y-intercept of -1, so that's going to be here. And I have a slope. Remember, there's a +1 there, so I have a slope of 1. So again, it's a dashed line, just like the other two were. Okay. And this is y is greater than. So my line looks something like this. I'm already through that region accurately. Okay. And so now I'll make a note to myself that I'm going to shade that part. So now where is my triple shaded region? I have 3 graphs. That means I'm going to have a triple shaded region. So I'm going to shade below the black line, to the right of the blue line, and above the orange line. That leaves me with a triple shaded region right in this triangle in the middle here. Okay? Cool. All right. One more thing, and then we're done for the day, and you guys will have a worksheet that the sub will pass out to you. We have to be able to work backwards, and we have to be able to look at a graph and then determine what is the system of linear inequalities. So basically, we have to figure out what the 2 linear inequalities are. So I'll call this A and this one B, just so you understand which ones I'm talking about. And so I will do line B. So what we're looking for is to try to fill in y, some inequality symbol, blank x for my slope, plus blank for my y-intercept. Well, if I'm doing the line for B here, I know it's a horizontal line, right? So horizontal line has a slope of 0, and where does it cross the y-intercept? It crosses here at 2. And now we have to decide what my inequality symbol is going to be. Well, it's a dashed line, so I'm not going to have a line underneath my inequality symbol. And we have shaded below, so that means it's going to be less than. And I can simplify this just by saying that y is now less than 2 because 0 times x goes away. So that's one of them. Okay, so now let's do equation A. I'm going to do the same thing. Y, some inequality symbol, blank x for my slope, and then blank for my y-intercept. Well, where does it cross the y-axis? It crosses here at 1. So my y-intercept is 1. What is my slope? From point to point, I go up 2, right 1, up 2, right 1, up 2, right 1. So my slope must be 2. And now I have to do the same thing to figure out my inequality symbol. I have a solid line, so I'm going to have a line underneath. And I'm shading above that line, so it's going to be greater than. So I have y is greater than or equal to 2x plus 1. And that's how I can identify. Now I have my system of inequalities between those two, and I'm finished. Okay? So, combining a lot of different things today. Two things you already know, how to graph linear inequalities, and doing 2 of them or 3 of them on the same set of axes here. So you guys now have a worksheet to work on. Hopefully you guys paused the video as we went along and got stuff filled in. If you need to go back on anything, that's fine. You can also access this video on the Moodle page. I hope you have a great day, and I will see you guys on, today's Tuesday? I'll see you guys on Thursday for the test review. Take it easy.